In section 14.3, we are going to go over right triangle trig, which we did in geometry. It was in chapter 9, and I know you learned it because I'm the one that taught it. So we are going to review quickly. It's a long, kind of a long lesson, so I'm going to talk quick and try to hit the highlights. When we are doing the trig ratios, two of the relationships that we need to know are opposite and adjacent. You're always going to be evaluating from the acute angles, so from angles A and C. Depending on the perspective, if you're at A, the opposite is down here, adjacent is next to it. If you're at C, opposite is across to the left, adjacent is at the bottom. But notice that the hypotenuse stays the hypotenuse. So when we're dealing with trig, there are three ratios that we learned. There was sine, cosine, and tangent. And we learned the mnemonic SOHCAHTOA, where each letter stood for, or it was the first letter of every word. So SOH, sine is opposite over hypotenuse. CAH, cosine is adjacent over hypotenuse. TOA, tangent is opposite over adjacent. Now, the new part of this lesson is learning that each of these have a reciprocal ratio. So the reciprocal of sine is what we call cosecant, abbreviated CSC. The reciprocal of cosine is secant, SEC. And the reciprocal of tangent is cotangent, COT. And reciprocal means flip. So all you're doing is you're taking the original three ratios and you're flipping them. So if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. If cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. If tangent is opposite over adjacent, cotangent is adjacent over opposite. And there are a lot of things that we learn to do with these ratios. The first being just writing ratios themselves. And remember, ratios are just fractions, so that's what we're looking for. So when you are asked for the 6 ratios, here's the trick. You got to look at this triangle and hopefully you realize you're missing the hypotenuse. So we want to use the Pythagorean theorem to help us find that hypotenuse, or you may know that it's a 3, 4, 5 triangle. So because of that, since we're evaluating from angle D, 4 is on the opposite, 3 is on the adjacent, 5 is on the hypotenuse. And so when you use your ratios from above, these are the fractions that you get for these answers. So if you need to scroll back up and look at the ratios or pause, now's the time. Another example would be for this one. The only reason I'm showing you this is simply because of the roots. When you're asked to find the 6 ratios, again, notice that you're missing a leg. So you've got to do Pythagorean theorem to find the leg. What's going to happen is when you solve, you're going to have to factor tree, and you should find that this bottom leg is 8 root 3. Now, if we're evaluating from P, 8 is on the opposite, 16 is on the hypotenuse, and the 8 root 3 is on the adjacent. So then when you use your ratios from above, SOHCAHTOA, you'll find that you get these values for sine, cosine, and tangent. Just remember on tangent, you're going to have to rationalize because we can't leave a root in the denominator. Now, for the reciprocals, all you have to do is flip these answers. So if sine is 1/2, when you flip that, that would just be 2, because we wouldn't leave it 2 over 1. If cosine is root 3 over 2, when we flip it, it would have been 2 over root 3, but you have to rationalize. And then on cotangent, instead of flipping the final answer of tangent, go back to what tangent first was, 1 over root 3. If you flip that, then cotangent is just root 3. So then you don't have to worry about rationalizing again. Not only can we write ratios, but sometimes we have to find the ratio of a particular angle and we don't know what the triangle looks like. So that's where our calculator would come in. Make sure that you're in degree mode. So on your graphing calculator, press mode, which is right next to the second button, and make sure that degree is highlighted. And then you're going to type it in how you see it. So there's some examples here. The answers are to the side. You can try it and make sure that you're getting the same answer. If you're not, then you're not in the right mode. You need to fix it. Now, another way that we can use our calculator is to do the inverse function so that we can find an angle. So instead of above where it says sine of a particular angle, cosine of an angle, tangent of an angle, now it's asking sine of what angle is equal to 0.2846. So what you're going to do is you're going to press second and then sine 0.2846, and that would give you 16 degrees. You can try these as well. You're going to press second cosine, second tangent, second sine, and these are the answers that you should be getting over here. So you may want to pause so that you can take a moment to practice that. Now if we put it all together, the calculator and the ratios, that's going to help us solve triangles. Anytime you are told to solve a triangle, that means you are supposed to find every angle that's missing and every side that's missing. So notice that we are missing angle A, we are missing little side A and little side C. Also notice that you have angle A and opposite that is lowercase a. Angle C, opposite that is lowercase c, which means this angle B, opposite that, the 12, that would actually be side B. That's our hypotenuse. But we're going to start with the angles because the angles of a triangle add to 180. So if you take 90 and 37, subtract that from 180, you're going to find that angle A is 53. But we want to use the 37 and the 12 because that's what was given to us. So I'm just going to start with finding side C. It doesn't matter what you find first. From 37, C is on the opposite, 12 is on the hypotenuse. Going back to the ratios, what uses opposite and hypotenuse? That would be the sine ratio. So what that means is sine from 37 is equal to C over 12, opposite over hypotenuse. Because we could also read that as C divided by 12, then to solve for C, we just multiply by 12. And on your calculator, if you press 12 sine 37, that'll give you 7.222. To solve for A, notice that A is on the adjacent, but 12 is still on the hypotenuse. So for adjacent and hypotenuse, that would be the cosine ratio. So that means cosine from 37 is equal to A over 12. That's adjacent over hypotenuse. Again, because that reads A divided by 12, then to solve for A, we will multiply by 12 to get 9.584. The next examples are similar. There are a couple of differences, so I'm just going to point out the differences. I'm not necessarily going to go through everything. You can read through it on your own and just take note of what we're doing. When we solve for F in particular, okay, side F, I'm going to go back up real quick. Sorry. From the 65 that's given, we have 10, which is adjacent. And if we want to find F, that's on the hypotenuse. So adjacent and hypotenuse would be cosine. So that means cosine from 65 would equal 10 over F. That's adjacent over hypotenuse. But notice now that F is in the denominator. You cannot solve while a variable is in the denominator. So what we're going to do is, it's a shortcut, so just take my word for it. You're going to take the F and the cosine of 65, and you're going to switch them so that you have F equals 10 divided by cosine 65. So you're going to type it just how I read it. 10 divided by cosine 65 equals, and that's going to give you the 23.663. So here's the difference. When you have a variable in the numerator, you're going to multiply. Your variable's in the denominator, you're going to divide. That's how it works every time. Now, what happens if you are just given two sides and no angles? So the first thing you would do here is do Pythagorean theorem to find the hypotenuse, and you're going to find that that's 25. But we also need to find angles M and P. So it doesn't matter which one we start with. If we just start with M, from M, 24 is on the opposite, 7's on the adjacent. Opposite and adjacent is tangent. So tangent M is equal to 24 over 7. But because it's an angle, you have to press second and then tangent. 24 over 7 equals, and that'll give you 73. Now if we wanted to solve for P, Now 7 is on the opposite and 24 is the adjacent. It's still tangent, but when we write tangent P, it would be 7 over 24. So if we press second tangent 7 over 24, that'll give us 16. On your homework on 796 for number 2, just write the fractions only. You don't have to do the decimals. And then you're doing 5 through 7, 36 through 38, and 44. You may have to draw the triangle on your own. Just remember, like I showed you at the beginning, when you have an angle A, then opposite it is side A, angle C, side C, angle B, side B. Just make sure you label that correctly. And if you're asked to solve a triangle, then that means you find every missing angle and every missing side.